Now that we had a closer look at arrays, a super important data structure in JavaScript, let's have a look at objects as well, because objects are an even more important data structure in JavaScript. Actually, arrays are just objects in the end. And with objects, we can do a lot in JavaScript. They're super important for grouping data, for also grouping functionality, something we haven't really done yet, but which we'll also dive deeper and deeper into in this module and the subsequent modules. And a lot of things in JavaScript are objects. For example, when we worked with the DOM, where we add a movie here with this form, if we have a look at that code there, of course our movie which we add is a JavaScript object, which we use to save the data about a movie in our code so that we can work with it. But every DOM node to which we get access with getElementById or any other selection method, or any DOM node we create with createElement, all these things are in the end just objects, just JavaScript objects. Sometimes created by us, as in the case of new movie, where we use this curly brace syntax, and in other times created by the browser for us, where we then just get access to these created objects, for example with such selection methods. So objects are everywhere in JavaScript. They're super important and there's so much you can do with them. So in this module, we will have a closer look at objects, what we can do with them, which different syntax features we have to work with them, and much more. Now, to start, let me again clarify what exactly objects are. Now, of course, we worked with objects a lot throughout this course, but it's super important to make sure that we all understand and are on the same page regarding the definition of objects. Now, objects are core data structures in JavaScript. An object is a super important data structure because it typically is used or helps us reflect real-world entities. Now, this might sound strange. What does this mean? It means that with objects in JavaScript, we have a way of working with things like buttons or movies, which are things to us, right? A button, even if it's on a web page, which is digital, of course, even there, it's a thing to us humans. We all know what's meant if I talk about a button on a web page. We have something in mind if I talk about a movie. It's no coincidence that when we then create a movie here, for example, in code, it has things that would make sense for a movie to have, a title, a preview image, basically, a rating. So we can think as we think in the real world, but now when we write our code. And that's how we do want to write our code. We don't want to write some abstract code which you don't really understand if you're not a programmer. You might not understand the syntax, but having a look at that, it's probably fairly easy to understand that we're describing a movie. We might not know what we do with it, but this describes a movie. So that's the idea behind objects. We describe real-world entities. We allow ourselves to write code that makes sense to humans, if you will. So we can apply our real-world logic to coding in the end. Now, technically, objects in JavaScript are, of course, data structures that are made up of properties. These are these key value pairs, and methods. Methods in the end are also key value pairs, but the value is a function that's tied to that object. So you could say properties are variables in an object, methods are functions in an object. So we use properties to store data that somehow is related in one and the same object, and then maybe some actions that make sense for this object. Now, we haven't worked too much with methods throughout this course. That will change in this module, and that will actually be a very powerful feature when we work with objects in JavaScript. So in the end, objects allow us to group related data together, and also they allow us to split our code into logical pieces. We don't have to manage everything in tons of variables, which are thrown into our script file. Instead, we have some objects that help us do different things. Now, of course, there's a broad variety of use cases for such objects. You might have simple objects like just a movie, which you use somewhere, and more complex objects like such a DOM node, which actually has a lot of built-in methods that help you interact with it, query its children, and also a lot of built-in properties that help you style this node or change its value or whatever it is. So there are a lot of things you can do with it depending on which kind of object you're working with. So objects are extremely versatile and in the end power JavaScript. So what is an object in JavaScript then, or how do you see that something is an object if you didn't create it yourself with the curly braces? Well, in JavaScript you must never forget that you have two types of values, primitive values and reference values. And in the end, reference values are objects. So only objects are reference values, to put it like that. Now, primitive values are these types of values: numbers, strings, booleans, null, undefined, and symbol. And we haven't had a look at symbol yet. It's an advanced niche type, which I'll cover way later in the course. But the other types should be familiar to you, especially numbers, strings, and booleans. Now, on the other hand, reference values, as I said, well, that are just objects. So everything else with which you work, for example, DOM nodes and so on, well, that's an object. Objects are the things you create on your own with these curly braces. This is called the object literal notation to create an object. So you're creating an object by creating or by writing such an object literal. But we also, for example, have arrays. And whilst arrays are, of course, specific types of objects, with that length property which automatically adjusts, and with that special functionality where we can use it in a for-off loop. We can't do that with any object, only with these iterables, as you learned. So arrays are special types of objects, but they're also just objects in the end. DOM nodes, well, these are also objects. The things which we select in our DOM, these are objects. And much, much more. Anything which is not a number, a string, a boolean, null, undefined, or such a symbol, and you don't have to worry about the symbol here, that's not something you'll encounter in your normal JavaScript code. So anything else is an object. So now that we clarified what objects are, let's dive into some code. Now, for this module here, I prepared a simple demo application for you again, where we will actually do more than just log stuff to the console. Again, we're back to some movies. Here we'll later be able to add our favorite movies, add some extra information of our choice to them, and then add them to a list, which we then can even filter. So where we can enter a search term and filter. Now we start with absolutely nothing because we have all the tools we need, but we also won't dive right into this app because there are a couple of things I want to recap about objects, and I want to introduce about objects which we haven't learned yet. So before we work on the actual application here with all the logic we need, let's quickly make sure we all understand what an object is. Well, I guess we already did that, but let's create one. So we can create an object and store it in a constant or in a variable. Both works. It's a normal value in the end. And for example, create that good old person object with which we worked multiple times already. Now we create it here with the curly braces, and that's the object literal notation as it's called. And in there you can have these key value pairs. Now, as I said, properties are key value pairs which store some static values or some values and not functions basically. And well, if you store a function as a value on a certain key, then this is called a method. Now both properties and methods are created here by entering some name of your choice, for example, name, and then a colon, and then the value. Important, in here, you don't have any const or let or anything like that. You just have name or whatever name you want to use for your key, colon, and then the value, for example, max. Now we can also add an age here, for example, and store 30. We could add hobbies and have an array in there. An array is an object, and therefore this, of course, proves that we can have an object inside of an object. That is absolutely okay. There we could have sports and cooking as hobbies. And we could also add a method, for example, greet, which simply is a function assigned to a property here, where we can then, for example, use the console here for the moment, or also alert, of course, to show an alert box where we say, hi there. Something like that. Now with that, we created a person, an object, and we can interact with that dot notation. We did this multiple times, so this is probably not new. You can enter a dot, and now you have access to all the properties and methods that are stored on this object. For example, .age, .greet, which is a function and which we therefore can call as such, and so on. And hence, if I, for example, save that code, and we go to our site, this is, by the way, what's getting rendered with that HTML and CSS, which is part of the project, and we reload this, we see hi there before this renders. So This is what happens here with this basic object, and thus far that's nothing too new. Now let me dive into some new things regarding the properties, how you can add them dynamically after an object was created, how you can delete them, and which restrictions but also flexibility you have when it comes to picking a name and to accessing a property. So our basic object here, of course, works. Now let's say we created an object and then for whatever reason, maybe because a user clicked a button and that triggers that we want to edit this object, we want to add a property after this object has been created. Now there are two approaches. The more complex approach would be to create a brand new object. For this, we would have to turn this into a variable so that we can assign a new value to person, because with a const this would not be allowed. If you have a constant, you must not ever assign a new value to it with that equal sign. And then we could recreate this object here. Now we can copy over everything from there and of course then add whatever we want to add. Let's say is admin true. Now of course that's super complex and not really what we might want to do. Also, if we changed some value here, we have to ensure that we pick up any changes that were made between this declaration and this reassignment. So in some code in between. So this is typically not what we might want to do in most use cases, and certainly not manually by copying all the code. Instead, what you can always do on JavaScript objects is you can use the dot notation and simply access a property which you haven't added before. For example, is admin. At this point of time, person has no is admin property. We didn't add it here, but you can do this here. Now, if you try to log this, you'll also not get an error, and I'll remove that greet function call here so that this alert doesn't always open. So if we log that, we won't get an error. Instead, we just log undefined. That's also something to keep in mind. If you access a property on an object which doesn't exist, you're not getting an error. Instead, you get undefined. But what you can do is you can simply assign a value to this property now, even if you didn't define it before. You can simply set this to true, and if you thereafter console log your entire person, let's say, you'll see that isAdmin is now a part of that person. So if we reload this and expand it here, we see isAdmin has been added. So adding properties on the fly is super easy. You just access them with the dot notation and assign a value, and it doesn't matter if that property was part before or not. If it wasn't part of the person before, it's now added. If it was part, so if you would set person age to 31, for example, well, then we of course overwrite that old value. So we either overwrite or we add, and both works. Both is supported, and that of course gives us a lot of flexibility there. Now, sometimes you also want to get rid of a certain property. Let's say you want to make sure that you actually delete the age here. So instead of reassigning it here, we want to get rid of a property. That's also possible with a special keyword JavaScript provides to you, the delete keyword. You just type delete like this, then a white space, so that this is a standalone keyword, and then simply person dot, and then whatever property you want to delete. For example, age, just like this. And this will delete the age property from the person object. So if we now save that and we reload, you will see that in the logged person, age is missing. So if you ever want to remove a property, that is one way of doing it. Now, always keep in mind, if we thereafter try to access age, we'll not get an error, we'll just get undefined. So deleting a property is basically as if you would set it to undefined. So if I reload here, we see undefined gets logged here. Therefore, another way of getting rid of a property is to use person.age in this case here. So instead of using this, and setting it equal to undefined. Now, this is not super clean though. It will work, it will do the trick, and you can technically use it. But it is a good rule to keep in mind that you should actually never assign undefined to any value. You might remember earlier in the course I mentioned that we have undefined and null. Null is the value we use if we want to reset something, if we want to clear something. Undefined is a value which we as a developer never actively assign to anything. Instead, undefined just is a default value JavaScript assigns to uninitialized variables or properties in this case. So doing this technically works, and you can do it. Of course, it's not a hard rule that you should never assign undefined to anything, but you might consider, if you really want to do that, this here might be cleaner. It clearly expresses what you want to do. The effect here is the same. Now you would, by the way, not have the same effect if you would set person age to null. This will reset it, but what you'll see is that if you now reload this, we log null here, and if I log the entire person, you will see that age is now still an active property of person, so to say, because null is not exactly the same as undefined, as you also learned. It's not exactly the same. They are of different types in the end, and therefore it's a difference if you set something to null, which really just means the person has this property, we just don't have a value in there right now, or if you set it to undefined, which means this person doesn't even have a age property. And important, setting it to undefined means it doesn't have a age property. Technically, if you console log the entire person, no matter if you set age to null or undefined, the property, the age property, will be there. It's just null or undefined. The meaning is a different one if you set it to undefined versus to null. What you mean as a developer is different. Technically, it's always there. If you really want to clear the property and get rid of it and make sure the object doesn't even have the age property anymore, delete, the delete operator, is the way to go. Setting it to null or undefined has different meanings. Null means I want to reset it. I deliberately want to set it to null, but I want to make it clear that it should still be there. Undefined means it's technically still there, but I really want to emphasize that it doesn't matter anymore. But technically it's always there. Delete is the only way of getting rid of it. So these are tiny things where you want to be careful. If you do that, you typically do that in situations where you say, I'm going to assign some age later, probably. I just don't have one right now. Whereas if you delete it, you're basically saying, I don't need that age on that person anymore. I will never use it anywhere else in this program. So these are the subtle differences when it comes to deleting and resetting properties in objects. So we know how we create an object, how we can dynamically add properties, how we can delete properties, how we can read properties, and how we can call functions in objects. Now let's have a closer look at the property names we're using here, so at these keys. Thus far, I always used keys, well, like this, basically as I would use them for variable names. Anything which you can use as a variable name can be used as a key name. And keys are even more flexible than variables. So everything which you could use on a variable can be used as a key, but not everything which you can use as a key name can be used as a variable. And here's an example. Let's say I don't want to have name here as a key, but first name, but also not written like this, but let's say written like this. Now, as you already can tell, my IDE gives me an error here, because this actually is not a valid JavaScript syntax. Having two separate words here, JavaScript doesn't know what you mean by that. It tries to understand how these two words work combined, and it sees that first is neither an operator nor some other keyword, so it doesn't know what first should do to name. And that makes sense, because if you had a variable or a constant, you could also not use first name like that. That's not supported, right? You must not have a white space in your variable name. It always has to be exactly one word, without white space, without dashes, and so on. Now, the same is generally true for these object properties. First name like this, for example, is also not allowed. But you have a way around that. You can use any string as a key in an object. And actually, any key you enter is automatically coerced, which is this behind-the-scenes automatic conversion, you could say, to a string. So even age is kind of converted to a string in JavaScript. So an object really just is a dictionary, you could say, of keys, which are string values, and of then values, which can be of any kind of value. And for first name, JavaScript is not able to automatically convert this for us, because before this code runs and JavaScript has a chance of converting it, it already breaks, because it, first of all, tries to interpret this in another way, which is not valid. Now, therefore, for names like this, we have to tell JavaScript that no, we want to use this as a key. It's not some calculation which you should perform or anything like that. It should just be a key name. And how could we tell JavaScript that this should be a key name, which in the end is just a string? Well, we just wrap it in quotes. Single or double quotes does not matter. Either way works. So you can just use any string here as a key name, with a dash, with a white space, with multiple words, whatever you want. These are all valid key names. Now I will say that names like this are the exception though. You typically use names which you could also use on variables, because on variables this does not work. That's just an important side note. You can't have const first name. This does not work, as you can already see in the IDE. This is really exclusive to objects. And again, whilst you can use it there, it's not so common to use it like this. But let's say we have first name like that. Now we have a new problem. How do we access this? Well, you would say, okay, person dot first name. But we have pretty much the same problem as before now. JavaScript tries to parse this as an expression. And in JavaScript, this is never a valid syntax. Having two words after each other only works if one of the words is an operator or some keyword, like here with delete personage. With this delete keyword, this delete operator here, well, JavaScript understands this and then it can have a look at the thing after that keyword and see how that is affected by that keyword, by that operator. Now it tries the same here and it sees, I don't know first. It's not a built-in keyword, it's not some operator which I know, so I don't know what to do with that and what to do with the thing after it. Therefore, this doesn't work in JavaScript. So how can we now access this key name, which I told you is valid, and which we see, we're not getting an error here, with this notation? Well, the answer is with this notation we can't, but there is an alternative way of accessing properties on JavaScript objects, and that's the square bracket notation. Now we know this notation from arrays. In arrays, we could also use that to access the elements at certain indexes. In the end, that makes sense because arrays are just objects, and this is basically just a general object notation. For array objects, we just have that built-in special behavior that we have certain methods to add elements to the array, and they automatically get the indexes assigned and so on. But other than that, we have this square bracket notation available on any object. Now what we enter here is now not an index number, because this person object doesn't have indexes, it's not an array, but instead here you can enter any key name. But, and that's now important, not like this. This would look for a variable age outside of the object and then try to read that variable's value and find a key with that variable's value in here. Instead you pass in a string here. So here you can then type first name, and this is now how you can access the first name of person with that square bracket notation. So now if we save that and we reload here, we see Max being printed here, and that is the result of that property access with square brackets. So this is really important to know, that you have this alternative and that this allows you to use key names which you normally could not use without the quotes around them. By the way, this is also pretty interesting because you might remember that on DOM nodes, when we worked with the styles, for things like background color, we had to use this camel case notation. Let me quickly show you what I mean. We have a bunch of stuff here in our HTML file, and let's say I want to select that movie list for now. That's in the end an unordered list where I later want to output the movies we added. So right up here, I'll add movie list with document get element by ID. That's something you learned. So now we have access to that movie list, and here we can access the style object to work with the different CSS styles. And as I said, we can, for example, access background color, color written like this, and set this to red. And we have to use this notation because background color like that would not work, and therefore JavaScript automatically gives us these translated property names, if you want to call them like this. So now we could see that, however, for this movie list, we'll also have to set the style of display to block, because by default it's hidden at the moment. So with these two lines added, if we save that and we reload, we got this red background down there. Now, the interesting thing is, with the square bracket notation, we can of course also access background color like that, however not exactly like that, but with quotes around it, as I mentioned. Without quotes, this here would lead JavaScript to search for a background color variable in our other code and use the value inside of that variable to then look for a key on the style object with that variable's value. So we have to wrap this in quotes, and this will also work if we save that and reload. But the interesting thing now is that actually the style object does not only have these translated property names, but you also find the original CSS property names in here. Because if you wrap your property access in quotes and you use the square bracket notation, you can of course use background color like this, because your key is a string, and in the string you can have any characters you want. Dashes, white space, question mark, whatever you want, it's all possible. So therefore, now actually we can set the background color like this, and it will also work, as you can tell. So that's also nice to know, I guess, and it shows the power of this square bracket access feature and also of the flexibility we have, since we can use any string as a key name. And just again, because it's important, all non-string keys here which I have, like age and hobbies, are kind of automatically converted to strings, coerced to strings by JavaScript. Now, besides string property names, there are two other kinds of values you can use for your property names, and that would be numbers and also symbols. Now again, let's ignore that symbol thing, but let's have a look at a number. Now actually, it's not too surprising that we can use numbers, because that's in the end what an array does. It assigns indexes to our values. Well, in the end, as you know, an array is an object, so in the end it's just an object which automatically assigns number keys to the values you added. So here we could also add a number key, and for a person it doesn't make too much sense what would be a number here, but we could enter 1.5 here as a key and assign a value of hello or any other value. So now we have this here as a number. Again, behind the scenes it will still be coerced to a string, but you can use it as a number here and access it as a number. So for example here, if I store hello in 1.5 or in any other number of your choice, not including negative numbers though, so negative numbers are not allowed, must be a positive number, 0 or higher. But if we store that here, we can access this here with console log person, and now again not with the dot notation though, because this here will not work. You see I'm getting an error here. This is simply not syntax JavaScript understands. So therefore, here you also have to use square brackets, but now important, you don't have to wrap this in quotes here. Now here, JavaScript clearly detects that this should be a number. So now, since it's in the same pair of square brackets, this is evaluated as one thing and therefore as one number. And hence, if I save this, we see, if I reload here, hello down there. Now you can also wrap this in quotes if you want. So you can do that and then reload, and it will work as well, because as I mentioned, JavaScript automatically coerces values to strings. So it kind of translates it to a string anyways behind the scenes, but you can also access it like this. Now, storing numbers in normal objects is probably not something you'll do too often, but it works. And you see, this is how you can then access this. Now, one word about the order of properties. A common question is, how are these properties ordered in a JavaScript object? Now let's have a look and let's console log the entire person here. And if we do so, if we reload this, we now see the object here. And now here's something important. If you expand it here, you automatically get a sorted view of that. So here you always have that sorted. Now, if we have a look at that unexpanded thing, however, we see that we have the order in which we added our properties. So that's how our properties, our key value pairs are ordered. They keep the order in which we add things. So we have first name, hobbies, greet, 1.5 and is admin. And indeed, we have first name, hobbies, age is deleted, but then hobbies, greet, 1.5, and then is admin is added last, and that's exactly what we see here. Now there is one important exception which I quickly want to show you here. If we have an object which only consists of number keys, let's say you have 5 with a value of high and then 1 with a value of true, a string but can be any value, then if you output numbers, you see indeed here already that changed. So here that is sorted. If you have an object with only numbers, then the numbers will be sorted. That's important to keep in mind. Numbers will be sorted. Otherwise, if you have string keys, the insertion order will be kept. That's how JavaScript object properties are ordered by JavaScript. So we all want to get started with that app here now, and so do I. Just one more thing I want to get out of the way so that it's not confusing if we then later use it. We had a look at this square bracket notation to access key names, which we couldn't access with the dot notation. You actually can do more with the square brackets. One cool feature is that you can also dynamically access properties with this notation. Here I hard-coded first name in here. Now what if that would be stored in some constant, key name, or whatever you want to name that constant? So this constant holds a string, and now I know I want to access the property with that constant's value, so with this string, in person. Well, with the square bracket notation, you can access key name. Now without quotes around it, because I'm not looking for a property named key name in here, but instead I want to look for a property with the value inside of key name, so this here, in person. So that's also something you can do. That wouldn't work with the dot notation, because with the dot notation, JavaScript would always search for a property with the name key name in person. So not with the value stored in key name, but with key name as a name in person. And that of course doesn't exist here, so we would get undefined. With square brackets, we can dynamically look up values, and we can work with key name values which are actually stored in other constants or the result of any other expression. Could be a function call, could be a ternary expression. Anything that yields a value can be inserted here to, well, then access a key with that yielded value. Now, of course, in this little example here, it's still the same as if I would have hard-coded first name here, because I hard-coded it into this constant. But you will have cases in this little demo app we're going to build in this module already actually, where this is derived dynamically, and then this is really useful. Now, speaking of dynamic, there is another dynamic feature or thing you can enable with the square brackets and objects. And that's when you define properties. Now here we know all property names in advance. Now what if that's not the case? And we'll see an example for that in this app we're about to build too. Let's say we got some user input, user chosen key name, which is level. Anything like that was entered into an input by the user, so we as a programmer don't know this in advance when we write the code. Keep in mind, I'm just hard-coding this here as a dummy, as an example. But let's assume we got this from a dynamic input by the user, so we don't know it in advance, and now we want to add a property with that name to this object. Now, of course, here or wherever you want, you could think, well, I just add user chosen key name here and then store whichever value I got. The problem with that is this would add a property with the name user chosen key name, not with the value stored in the equally named variable. To do that, you use square brackets here, a place where we haven't used them before. So on the left side of the colon, where you set your key name, and you then reference that variable. Now what JavaScript will do is it will not take this as a key name it adds to the object. Instead, it will search for a variable of that name and take the value stored in that variable or constant, so in this case, this string here, as a key name which it adds to person. And then again, you can assign any value you want here. So you can not only use square brackets to dynamically access properties, but also to dynamically set them, which is of course really, really powerful. And again, a concrete example will be shown in this little app we're building. And with that, I'd say, let's get started and let's work on this app. So let's start working on our little demo application here. And for that, I'll clear all that code. I'll remove it all. Of course, if you want to still access it, you find it attached to multiple lectures in this module and on the lectures prior to this one, basically. And I want to start from scratch and work on this little demo application. The idea of this demo application is that we have this input area up there where a user can enter a title of a favorite movie, and then an extra information where the user can set the name of the property and then the value of the property. So you can probably already see where this dynamic square bracket notation will be able to help us. Well, if we then click Add Movie, that movie with that information should be added. and it should be output down there in a list of movies where we output the title and also the extra information. So of course the tricky thing there will be that we don't know the key name in advance. So we'll have to find some solution for that. And last but not least, we'll have that search bar here where we can enter some term or a part of a word and then search for that. And if the title of a movie includes that search term, we want to show it here. So all movies that include that part of the search term should be shown down there. So that's the idea. Now, therefore, here in Objects.js, I will start by selecting some things in the DOM, and that will be the Add Movie button, which we'll need to add an event listener to react to, well, clicks on this button here, and also the search button, which is that other button to which I want to add an event listener. Now, if we have a look at the HTML code, we see that this first button here, the Add Movie button, has an ID of Add Movie button, and the filter button here has an ID of Search BTN search button. So that's what we can use here. Good old document and then get element by ID, or use query selector, whatever you prefer. And then select the Add Movie button here, and also the search button with document get element by ID, and then it was search BTN. So these are the two buttons. Now, of course, we need functions that should be triggered when such a button is pressed, and I will start with the function that will actually add a movie, because searching for movies will be hard if we can't even add some. So here I'll again add a function, and you can use any way of declaring or of defining this function you prefer, with the function keyword declaration here, with a function expression, or with an arrow function expression, and I will use the latter. And then add my add movie handler here, which holds this arrow function here. But again, it doesn't have to be an arrow function. Now here in add movie handler, I want to gather all the user input and then add that to my movie. So for the user input, I have three inputs here. This input with an ID of title, this input with an ID of extra name, and this input with an ID of extra value. Now, I will select these inputs here in the add movie handler because I don't really need them anywhere else in my code. So there is no real need to declare them globally. And then we can have the title, let's say here, with document get element by ID. And then it was title, just title as an ID here. And that will give me the full DOM node, but I'm not interested in the full DOM node, but just in the value of that DOM node. Since it's an input element, it will have a value property which holds whatever the user entered. Now I'm also interested in the extra information. So I have the extra name, which I find on document get element by ID, and then that had the ID extra name. The value thereafter will have that ID of extra value. So here we access extra name dot value, because again, this yields us access to this input DOM node, and this will have a value property which holds the user input. And then here we have the extra value, which is document get element by ID extra value dot value. Now we can add some validation here and check if title trim is equal to an empty string, which means it's empty. And maybe also check with an OR separator if extra name trim is an empty value, or if extra value trim is an empty value. So if either of these inputs was empty, and if that is the case, I will just return here. You could also show an alert, but yeah, I'll just return here, not spend too much time on that validation. So now that we know that we do have valid inputs, I want to construct a new movie. So a new movie could be one constant name. The name is of course fully up to you. And this should hold an object created with the curly braces here, using this object literal notation. Now this new movie should of course hold a title, let's say, and the value for that will be title. And now here's a useful shorthand notation. If you have a property name which is exactly equal to your value name, so to the variable name you're using to derive the value you want to store in that key, you can actually omit the value name and the colon. And JavaScript behind the scenes will automatically set this to this here basically. So if key name and value name are the same, you can use that. Of course, that's not true if you had this here, for example. If you hard-coded a value of title as a string here, then you can't omit this. This can really only be used if your value is derived dynamically from some variable, and that variable name is equal to your key name. Then you can use this notation. So that's one thing, having the title here. And actually, I don't just want to have the title like this. Instead, I'll add an info key. And in that info key, I want to have an object which then holds that title key. So a nested object here. In that info object, which is part of the new movie, I then also want to add the extra data here the user entered. And here, of course, I don't know what the user entered here for extra name. So we can't use this notation here. This would add a key named extra name to a new movie, not use the value entered for extra name. Instead, as you learned here, we can use square brackets to assign a dynamic property name. Now, the value is also dynamic, but that's something we did before. We just point at the variable here on the right side of the colon, which holds the value we want to store in this property. So now we have the info nested object here in new movie. Now there's one other property I'll add next to info, so not inside of info, but next to it, and that's ID. And there I will use math.random using this globally available math object and the random method there to generate a random number as a pseudo unique ID. Okay, so that could be a movie here. Now I want to store that in an array of movies here. So I'll add a new movies constant here, which holds an array. And because an array is an object and therefore a reference type, we can store this in a constant and still edit the value here with push and pop and so on. And indeed, I want to push my movie onto this array. So movies push, new movie, like that. This alone will add it there, but of course it will not output something in the DOM. Nonetheless, let's console log new movie here to have a look at the new movie we created and see whether that looks all right. So we're now ready to test this. Of course, now we just need to connect this method to our button here. And that's also something we did many times. Reach out to add movie button, add an event listener, should be a click listener, and point at add movie handler. Don't execute it as a function here, just point at the name of the function instead, so that JavaScript calls that function for us. And with that, if we now reload here, we can enter any name of our choice, for example, JavaScript, the complete guide. And then here, any name of your choice as well for this extra property. I'll go with level, but again, you can use anything here. And then a value of 5 maybe, and then click add movie. And what we see is this object with a random ID. And then with this nested info object with level 5. Level is that property name I added here, written exactly like this. Casing is of course not ignored because JavaScript is case sensitive. And then here, the title, which I also entered here. We're not clearing the inputs, but I'm not interested in doing that here. Of course, you could tweak the code to do that. The important thing here is that we create that object. Now with that created, of course, I want to output it in that list, which should appear here at the bottom. So let's make sure that this is happening as well. So the movies which we have in our array should be output on our page. And for that, I'll add a brand new function here. And you can, of course, name it however you want. I'll name it render movies, like this. And in render movies, I will do something which is not the most ideal way of doing it, but which is good enough for this demo. I'll reach out to my movie list, so to this unordered list here in index.html with that ID here, with document get element by ID, movie list. And then there I want to render all my movies into this movie list. Now, the ideal approach would be that for every movie you add, you append one item to the already existing list. This is also what we did in an earlier module. Now here, to save some time and focus on objects, which is of course the core of this module, I will actually do it differently. And I will reach out to movie list and set inner HTML to an empty string, which will clear it. so that if something was rendered into it, it's now completely deleted. This is not ideal because now this means that whenever we add a movie, I clear the entire list and re-render it from scratch, which of course costs unnecessary performance. But again, I'm doing it here to save some time. You saw a different approach of appending one item after another in an earlier module. So here I'm clearing this. I also want to make sure that we can see the movie list to start with, because by default, if we quickly have a look at our styles here, we can see that movie list by default has a display style of none, and it only gets a display style of block if we add the visible CSS class to it. So therefore here, whenever we call render movies, I want to check if movies, so my array up there, if the length, which I can access with the dot notation here, because length is a property of this array object, if that is equal to 0, which means there are no movies, because if there are no movies, then I will reach out to the movie list and class list, and there call remove, and remove the visible class if it's on it. Else, I will reach out to movie list, to class list, and add the visible class, and this should then show it. Now we can also return here after removing the visible class, and therefore this inner HTML clearance can also happen after this if check. So now with that we have this logic in place. Now let's make sure we actually output the movies here whenever we call render movies, and we don't just toggle the visibility of the list. So I clear the current content here by setting inner HTML to an empty string. Now I want to go through all my movies and output them there. For that we can use a for off loop, or of course also movies for each to work with this as well, because we learned about the for each method in the arrays section, so why not? And as you learned, you pass a function to for each, which is then executed for every element in that array, and it will get the element as an input, so our movie here. You can name it however you want. I'll name it movie because it's in the end a movie. I don't care about the other arguments I could pass here because I don't need them. And now we go through all movies here, and with us going through all movies, I want to create new elements, new DOM nodes for every movie, of course. So here we can create a movie element, movie L, with document create element, and that should be a list item element, so with the HTML tag of li. And then here, to that movie element, I want to set the text content equal to movie.info.title, because remember, our title is stored in that nested info object in each movie. So we have to access .info. That yields us a new object, and on that new object we can access .title. So you can chain, that's how it's called, multiple property requests, so to say, after each other. And with that set here, of course, I also want to append that movie to the movie list. So on movie list, I will call append and add my movie element. Still in the for each loop, because that should be done for every movie. So with that, we just have to make sure we call render movies when we add a new movie. So here at the end, instead of console logging it here, I will call render movies just like this. So now whenever we add a new movie, it should be rendered. So now if we reload here and we add JavaScript, the complete guide, level 5, and I click add movie, you see that's getting output down there. And if I add another element here, that's getting output there as well. Now technically always everything gets cleared and re-rendered from scratch, and as I mentioned, that is not ideal, but for this demo it's absolutely okay. So now we're outputting this here, and we already use quite some nice object features. Now what we're not doing is we're not outputting the dynamic user chosen key value combination here, but I want to output this here as well. So let's see how we can do that. How can we now output the user entered key value combination? We can dynamically store it with this syntax here, but how can we output it? Well, of course, you learned how you can access dynamic values. You can also do that with the square bracket notation. You can set text content here to the title, plus maybe then a dash that separates it from another value, and then movie.info, and then square brackets, and now here we got the extra name, right? That's where we store the property name the user entered. So we can use that here, right? No, this won't work, because extra name is a constant in add movie handler in this function. We're now in a different function, and as you learned, variables and constants are block scoped, so we can't use extra name from this function in this function. Now, one, to be honest, dirty way around it would be to turn this in a global variable, which you set up there, which you assign here and then use here. This would be dirty and it would not even work, because keep in mind that add movie handler is called multiple times for different movies, where every time extra name could hold a new value. Now, if we only have one global variable where we store this value, then this will always hold the latest value the user entered, not all values. So here, if we then output this, we would also only output the latest value. So that is certainly not a solution we can use. Instead, we can do something different. Let me clear this line here, and instead let's add a new variable, maybe named text, where for the moment I just hold movie.info.title, which is the property we can certainly access because we hard-coded it, we as a developer, so we know it will be there. And then maybe add plus, and then a dash with white space around it. And now I want to go through all properties I have in new movie.info, and I know that every property which is not title will be a property added by the user. Of course, that will only be exactly one property, but still, that's the user entered property. Now, how can we go through all key value pairs in an object? You learned that in the control structures module, we have a special for loop for that, for in. With that, we can go through all keys in an object. And in this case, the object through which I want to go is movie.info. So this nested object inside of movie. This will now go through all properties I have in there, and that will of course include the title property, which I don't want to add again. So in there we can add a if check and check if key is not equal to title. Now here this has to be a string, because otherwise if you write it like this, JavaScript would look for a variable named title, which it won't find in this function, and it would then use the value stored in this variable for this comparison. So instead, since keys are strings, as you learned, we compare this to a string here. And if the key is not title, then we know we're looking at the property the user entered. Well, and this is then what I want to add to my text. So then we can set text equal to text plus, and then maybe string literal here using this notation with the backticks, where we can inject the value of key, because that will be the key name the user entered, so whatever the user entered in this field. And then maybe a colon. Now this is just a part of that string here, not some JavaScript syntax. And then the value. And the value, of course, is what was entered in this field here. And we can access this value by accessing movie info, and then with square brackets, the key. This is using this dynamic property accessing logic, where key is derived dynamically as part of this for in loop. Movie info is the object, and we want to access the value for the key with that name that is stored in that key constant here. And we do that with the square brackets. So with that, we dynamically access the value for whichever property name the user chose. Well, and with that, after the for loop, we can set movie L text content equal to text. So equal to that variable, which we are just inside of that for in loop. If we do that, we save that and have a look at this and reload the page. And I enter JavaScript here, the complete guide, level 5, and click add movie. You see this is getting output down there as well. So this now works, and this is how we can take advantage of this dynamic property accessing logic and of the for in loop to work with property names which I, as a developer, don't know in advance, because the user could enter anything in here, and therefore I'm not trying to guess what the user will enter here. Instead, we just loop through it, exclude the property we know that will be there, and then just dynamically access the value for the property which we don't know in advance. So it's time for the search logic then, because adding movies works, and I'll not work on making them deletable here, not really the focus of this module. But instead, let's make sure that we can enter some term here, something like complete, for example, and then we can click search and we would find this. But if I had another movie which doesn't include complete in the name, I wouldn't find this. So to achieve that, we need a new function here, which I'll name search movie handler, because it will be connected to an event listener. And this function here, in the end, I want to read whatever the user entered here, and then also trigger the render movies function. But then I want to tell that function here that it should not render all movies, but only filtered movies. So step by step. Let's first of all read the user input. And if we have a look at the index.html file, we can see that it's this input here with that ID that's interesting to us. That is where the user will enter the search term. So here I can get my filter term, or however you want to name it, with document get element by ID with that ID, and then dot value here. Just like that. Now that I know this, I want to call render movies and forward that filter term. Now, of course, render movies doesn't do anything with that yet, but that will soon change. For the moment, let's connect the search button here with add event listener, a click listener, and then point at the search movie handler here, so at this function we just added. Now, render movies now needs to accept that filter term, but not always, because here I don't forward it, only when the search button is clicked. And thankfully we learned how we can enable this, or how we can implement this. On render movies, we can work with a default argument. So I can add an argument here, maybe named filter, however you want to name it, and assign a default value, maybe an empty string. That means that by default, this will be, well, an empty string if we don't pass any more specific value. Then we can go to that part where we cleared the inner HTML. And now I want to tweak the movies through which I go here. That shouldn't always be all movies. Instead, I want to have my filtered movies here. So I'll add a new constant, filtered movies. And now that will either be all movies if filter is falsy, if it's an empty string or any other falsy value, or it will be my filtered movies if filter is a string other than an empty string. So we can check filter, so this parameter here, if it's not truish, so if it's not truthy, if it's falsy, then if it's falsy, I want to use all movies, because then we have an empty string or anything like that, and I want to use all movies because no filter was set in that case, basically. Otherwise, finishing this ternary expression here, otherwise I want to use movies.filter, and you learned about the filter method in the arrays and iterables module. Filter takes a function which executes on every element in the array, so I can pass it in as an argument to this arrow function in this case. Doesn't have to be an arrow function, but it allows us to write a really short function here. And I don't care about any other arguments this function would get. Instead, I just want to check if the movie I'm currently looking at, if that movie, which will be a string, if that includes, and there is an includes function on strings, if that includes a certain value. And here, I want to check if it includes my filter term here. Now let me reformat that. And with that, we're filtering all movies for only movies where the movie includes the filter term. However, of course, looking at the entire movie does not make sense. I should look at movie.info.title and check if the title of the movie includes the filter term. That's what I want to check. So if my movie, if the title there in the info object, if that includes my filter, then I will add it to movies, otherwise I will not. If no filter is set, well then I always use all movies. And now we can use that filtered movies constant here to go through it here with for each, because that will now be the movies that respect my filter I might have set. Now let's give it a try. Let's save it and reload. And quickly add JavaScript here, level 5 maybe. And then something else, maybe new courses ahead, level 10 or any other key value pair there. And now let's search. If I search like that, nothing happens. If I now enter Java here, you see only JavaScript is shown. If I enter new here, you see only new courses ahead is shown. If I search for level, nothing is shown because that's not part of the title. And if I clear that, again, everything is shown. If I just search for S, new courses is shown because it's a lowercase s and JavaScript only has an uppercase s here. If I search for A, both is shown because we have a lowercase a in both. So that's how this, of course basic, but nonetheless how this search works and how we can enable it with our JavaScript knowledge here and even bring some array magic to this example. With this example finished, there are more exciting things we can dive into when it comes to JavaScript and object syntax or JavaScript features that help us work with objects. One important thing, which I again want to emphasize, is the concept of chaining. Here we're doing something which is called chaining. We're having multiple dots in one and the same line, or to be precise, in one and the same expression, because we just perform multiple operations on objects or on values returned by prior operations. For example, movie.info returns an object, and therefore we can access .title on that object. We don't have to split this across multiple lines and store the result of movie.info in a variable and then use .title on that variable. We can all do it in one line. This concept of chaining is not only available on properties, but also on methods. For example, here with the ID, math.random uses this built-in math object to generate a random number. Now it turns out that numbers in JavaScript also have a method you can use, which is called toString. Actually, everything in JavaScript has this toString method. Now what I'm doing here is I'm chaining the toString method on the result of math random. So random is called on math and gives me a random number, and toString is then called on that number. So this concept of chaining and this term, this special word, chaining, that is something you should memorize because you'll see it a lot in most programming languages and especially in JavaScript. It is a common thing to do. It simply saves you the hassle of splitting code unnecessarily across multiple lines with helper variables in between. We also have another nice feature in JavaScript, which we don't really need in this app, but which we will need in general from time to time in JavaScript. And that's the spread operator in combination with objects. Now we saw the spread operator in combination with arrays, but we can also use it in combination with objects. And I will actually show this here in the console because there isn't really a great place to apply it in this dummy project. So let's say here we have an object, good old person, and that person has a name, Max, and maybe has some hobbies, which is an array where I have sports and cooking, close the array, close the object, and we're done. So that's my person here. Now, if we want to copy that, for example, into a new person, so another person here, then we can try it like this, but as you learned, objects are reference values. So if I now set person age equal to 30 and I add this new property, another person will also have it because it points at the very same property in memory. Now we can avoid this if we want to by using the spread operator. For that, if I create yet another constant, person2, however you want to name it, you can create a new object with curly braces and then use the 3 dots just as you do it on arrays and then add that other object you want to spread into this object. What this does is it takes all key value pairs of that object you pass after the spread operator and merge these key value pairs into this object. So it creates a new object but copies over the values you have in the keys of the old object, and not only the values but also the key names. If you do that and I set person age to 31, you will see that person 2 still has that age of 30 and didn't get that new value because now we created a copy. Now beware, just as with the arrays example earlier in the course, if you have other reference values inside of your object, like the hobbies array, an array is an object and therefore is also a reference value, then this will not be copied. Instead, well, it's of course kind of copied over into the new object, but the object is not cloned, it's not copied. It's still the same array object in memory. So if I go to person hobbies and I push a new hobby of coding, you will see that person 2 also has that on his hobbies if we expand this. Here we also see coding now. And that's just something which I explained in the arrays section already. This is normal. This is how reference values behave, and the spread operator does not do a deep copy where it goes through all level of nested reference values you might have in this object or array and then copies it from scratch. Instead, it just copies the top level key value pairs into a brand new object, and any nested reference values are kept. The addresses there are kept. There are no hobbies created. If you would want to copy those as well, you would have to do it manually by assigning a new hobbies array where you copy over the old array. And that's actually quite interesting to see. So let me show you how that would work. We have person 3, and again I copy person, let's say, but I want to make sure that hobbies is actually overwritten with a new array. And we cannot just use this technique if we want to overwrite another nested reference value, but whenever we want to overwrite a value. So let's say we also want to overwrite age. Well, then we just add age here and set this to, let's say, 30 or 29. And what this will do is it will pull all key value pairs from person, including age. But since then you again add age after this finished, the age that was pulled out of person will be overwritten with this value. And the same, of course, can be applied to hobbies. I set hobbies here to a new array, and now we can use a spread operator here in the array, which you also learned, and for example, spread everything we find in person.hobbies, so all the array elements in person.hobbies into this new array, and therefore we now create a clone of that old array as well. So now we create a brand new array here instead of copying the old array address. And hence now we would have a new object with a new array in there. Now it's not a must do that you always do that if you have nested reference values. You don't always need to copy everything. It's just an option that you can do that if you then plan on changing hobbies, for example, on person, and you don't want that reflected on your copied persons. Then you would have to use that approach. If you don't plan on changing hobbies ever, well, then you of course don't need to create that deep copy, because ultimately every operation costs a little bit of performance. So if I now hit enter here and we have a look at person, we see there age is 31, hobbies is an array of 3 items. Person 3 also has an array of 3 items, but age is 29 because we overrode it here. And if we then go to person and there to hobbies and we pop off the last element, we see that for person, now hobbies has 2 elements. For person 3, we still have 3 elements in the array because we did create a brand new array and copy over the old array values as well. So that can be a nice feature, being able to use that spread operator on key value pairs in objects as well. Perfect for creating copies, and then as you see, copies where you can still overwrite certain parts of the things you copied. Now, if we talk about copying, we also have to talk about another way of copying values. And for that, I reloaded the page, and I'll again start with my name, Max object here. And now if I want to create person 2, of course, we can use that spread operator, which actually would be my recommendation because it's a really short syntax. But there also is another approach, which simply has been around for longer and has a bit of better browser support, though as you will learn in the browser support module, that might not matter for you. And that other approach is to use object.assign. Now, object is a globally available object, actually in JavaScript, and it has an assign method where you pass in a target, which is, for example, a new object you create, and then the object where you want to copy over your values, like person. Now, you can add multiple sources where you want to copy over key value pairs, and in the end, object assign will spit out a new object here then and merge all key value pairs of the other arguments into that new object. And you, by the way, don't have to use it to create a new object. You could have an existing other object which has its own properties already and merge in properties of other objects into that. That would work as well. But a common use case, which you'll see, is also exactly this use case, where you assign properties of an existing object to a new object with object assign. By the way, when I say properties, the same for the spread operator, I also always mean methods as well. So both is copied over. So here, if I hit enter, you will see person2 now also is a copy of person, and it's actually a copy where we have a real new object, as I can prove by changing the name to Maximilian, for example. Person2 still has Max here, because here we created a real new object and just merged the key value pairs into it, just as we did with the spread operator. Now again, the spread operator would be my recommendation, simply because it's a bit shorter. So that's it for the spread operator. Another nice feature, which I can show you here in our little app, is object destructuring. You might remember array destructuring, which helped us pull out elements of an array and store it in variables. Well, you can do the same for objects. And we have a great example here, actually, where we render all movies. I go through all my movies here with 4 each, right? And I go through my filtered movies there, of course. And in there, I then have this for in loop where I go through movie.info. And I also extract the title from movie.info and the key from movie.info. So I always repeat movie.info. So in the end here, you could say, I'm really just interested in the info property of movie. I'm not interested in the other properties of movie or the other property of movie, which would be the ID. So here we can use object destructuring to pull out that key value pair and store it in a new variable. For example, here we could add a constant, and now, just as with array destructuring, a syntax you haven't seen before, where you in this case have curly braces on the left side of the equal sign, something we didn't do before, and now on the right side, point at the object where you want to pull something out of it. So in this case, movie. Now, between the curly braces on the left, you now enter a key name which exists in that object on the right. So for example, info. And of course, you have to enter a key name here, which exists there. In array destructuring, you could use any names between the square brackets you had there, because in arrays, you access values by index and not by name, and therefore you could assign any name because the order was important there for pulling elements out of the array. For pulling properties out of objects, the order does absolutely not matter. Instead, the key matters. So you can only use info here if you have an info property name, an info key in your movie. So now with that here, we therefore pull out everything which is in info, which happens to be another object, but it would also work if that would be a string or anything like that. And now we have a constant named info available, which we can use here instead of movie info. So I can use info here, and info down there, because this is now a constant which will hold the value that was stored in movie.info, which is my object. Hence, if we save that and we reload and again add JavaScript, the complete guide here, level 5, that works just as before. But I'm not done with object destructuring. Just as with array destructuring, you can also use a rest parameter, 3 dots, and then, in this case, any name of your choice, other props or however you want to name it, and this will now collect all properties which you didn't pull out by name and give you a new object with all these collected remaining properties. So here, if I console log other props, you see this will be an object which in our case should only include the ID, because that is the only other property we have in there. So if I now save that and reload and again try to add a new movie to save some time, I'll just name it JavaScript. You will see this works, and here in the console indeed we have an object with only the ID key, which is that, well, combined this object with the combined remaining properties. Now, of course, we can also use the object destructuring here to, for example, pull out the title. Now, there's nothing wrong with accessing it like this, and since this is the only place where I access the title here, it would be perfectly fine to keep the dot notation. But to practice this object destructuring a bit more, here we could also use it on the info constant here, which holds an object, right? Because info is just an object here. If it wouldn't be an object, we couldn't use that, but info is an object. So of course we can destructure that as well with this syntax. And in info, we have the title and then, well, whatever the user entered here. So here, I can also pull out the title from info and store this in a constant. Now we can still then use a for in loop on info because this doesn't destroy the info constant or anything like that. It's still available. So if we then want to use info in other parts of our code, we can do so. But I can also pull something out of it here and then use just title here if I wish to. Now you can actually also assign a new name here. You have to pull it out by name because that's how objects work. You don't pull out by order. But if you want to use a different name, because maybe otherwise you would have a clash with another variable name you're using or anything like that, then you can assign a new name to that pulled out value by adding a colon here. So inside of the curly braces on the left side of the equal sign, inside of this destructuring syntax, you can add a colon, and now not to create a new object where you have a key name and a value, but instead to assign a new name to that extracted property. For example here, movie title. And now we could use movie title here because that will now hold the title value, so the value of the title property in that info object. And hence, if I reload this one more time and we try adding this, we should see that that still works just fine. As you can tell, everything is output correctly here. And we're taking object destructuring to the max. So a really useful feature to shorten code, write short and concise code, and also be able to get exactly what you want out of an object, especially useful if you use the same property over and over again in multiple places. Often when you write code, you can of course be sure about the existence of certain properties in your objects. For example, here, I know I will have an info property in every movie because I myself wrote the code that adds it. Now, depending on how dynamic your program is and how much of the data that you're working with has been entered by the end users, where you can't predict at the point of time you're writing your code what will be inside your objects, you might want to validate whether something is present. Or maybe you have some part in your code where this info property would be deleted and you're not sure whether that ran already or not. So sometimes you want to check if a property is part of an object, and you can do this in JavaScript as well. For example, here in the if check, you can use a special keyword that helps you find out if something is part of an object. You can use the in keyword. It works such that you check if, then the property name you want to check as a string, info, then the in keyword, and then your object. So we can check if info is in movie. If this yields true, we know movie has an info property, and now we could write code that should only run if we have that info property. If we want to check the opposite, we can wrap this into an extra pair of parentheses and add the exclamation mark operator here to check if that returns a false value, basically. So that's the in operator. Of course, here we could have also checked if info has a truthy value after setting it here, because that will hold undefined if there is no info key. So that would have been a perfectly viable alternative. But if you have some other code where you don't plan on using object destructuring and still it matters to you to know whether a property is part or not, you can use the in operator. Another way of checking this is to just use movie.info and compare if that is equal to undefined. You know that a property has a value of undefined if it's not there, if it was deleted, or if you manually set it to undefined, or if it never was defined in the first place. So if this is equal to undefined, then you know this property does not exist. So if this is equal to undefined, we have no info property. That's another way of determining whether you have that property or not. Now here, I don't need that check, but this is how you could check for the existence of a property in case you need it in your code to avoid errors where you try to work with a property that's not there, or where you maybe want to assign some dummy default value to a property if it doesn't exist yet. So that was a lot of important and very useful object syntax, which you'll encounter a lot throughout your JavaScript career. Time for something totally new. The this keyword. And what's the this keyword? Well, let's say on our movie here, we of course have our title, right? Now we want to make sure that we can actually output this title in all uppercase. Now, of course, that can easily be achieved if you go to the place where you use the title, here. And then, for example, since title is a string, there is a specific string method, which you just have to know, and hence I'm telling you right now. There is a toUpperCase method available on every string, and if we call that and reload here, and I add JavaScript, level 5, click Add Movie, you see JavaScript is all uppercase. Now that's not too fancy, right? Now we have to call toUpperCase here, and obviously, there is nothing wrong with that, right? Don't get me wrong. There's nothing wrong with calling toUpperCase here. But sometimes you want to bake certain logic into your objects. It would be nice if we had a method in here, for example, getFormatted_title or anything like that. So a function stored in here, which returns us this formatted title. This would be nice to have. Well, there is a specific keyword available in JavaScript, which you cannot just use inside of functions which are part of objects, but actually everywhere in your code, but which is most important when you use it inside of functions that are part of objects, and that's the this keyword. The this keyword can be quite complex, though actually it's pretty easy to remember what it refers to. Inside of a function, no matter if that function is part of an object or not, the this keyword will refer to whatever called that function, whatever was responsible for executing that function, you could say. Now you might say, that's me, the developer, but I mean in your code, of course. Now let me give you an example. Let's say here we want to return this.info.title.toUpperCase so that this conversion logic is inside of our object. That's something you often want to do in programming. You want to put logic into your objects. And thus far in this course, we always just used objects to store data. Nothing wrong with that, but you get more flexibility if you're willing or if you're able to put logic into your objects as well. Because then you have these shareable data containers, which do not just yield you data, which you then have to work with and maybe transform once you pulled it out of the object, but which also include certain included logic, which is kind of in a box, which you can just tap into to get it to run, to do something. And the this keyword is key here, because otherwise, without it, this here would not look for the info property in the object. This would look for some info variable around it and really behave strangely, or in this case, since we have no info variable, just fail. So this is the keyword to tell JavaScript, look into the object where this function is part of, though to be precise, as you learned, look at the thing which is responsible for executing the function, which typically is this object, since this function is part of that object, and then dive into some info property, into some title property, and try to call toUpperCase on this. Now with that, we can go to the place where we pull out data from our movie, and here this object destructuring where I get my title is no longer needed, but we can actually also use object destructuring on a method if we want to. We don't have to, but we can. So here, getFormatted_title is the name, and we can therefore just extract getFormatted_title from movie, not from info, because it's actually part of the movie object itself. It's not part of info. If I would put it into info, we would get problems in the for/in loop, where I would have to include it in my if check there, basically. So I'm just pulling it out of movie like this. And then here, where I need my title, I can just execute it as a function, because it is a function. Now let's actually not do this right now, however. I'll comment it out for a moment because right now we would run into a problem here which we don't fully understand yet. And instead, let's just do movie.getFormatted_title. You might think it's totally equal to using the structuring here, but it's actually not, and I will explain why in a second. For now, let's do it like this. So now I'm calling getFormatted_title on my movie object because it is a part of that movie object. It's a method in that movie object. And if I now save that and I reload and I enter JavaScript here, level 5, and click add movie, we see an uppercase title down there. So our method works and the this keyword works. Now, what is this referring to? I said it's the thing which is responsible for calling the function, and there's a really easy way of memorizing how you see what is responsible. It's always the thing in front of the function. So here we have a dot and then movie, therefore movie is the thing which is responsible for executing getFormatted_title. That's perfect because movie is the object with the title property in the info property, and therefore this refers to this movie object, and we can dive into info title to uppercase. Now, before we dive into the problems this can bring, let's first dive into an alternative method syntax, which you can also use. This is one way of defining a method. A shorter way is to remove the function keyword, remove the colon, and add the parentheses right after this property name. So you no longer have a traditional key value pair here with a colon, but instead you have this syntax. Side note, if you would use an arrow function here, well, then you need to remove that arrow as well. So this is now just a different shorthand for adding a method to an object. Behind the scenes, it's actually not exactly the same as this here, but for the moment we can ignore this. I will come back to this in a later module because it's a bit more advanced and it simply doesn't matter for the moment. So this is now a method and it behaves just as before. If we save that and reload and quickly enter JavaScript level 5 or whatever you want, you see that works. So that's a shorter method syntax, which I will now use. So now what's the problem with this? Let's go back to the place where we use getFormatted_title and let's go back to destructuring. So I pull out getFormatted_title from movie. We can still do that even with the shorter function or method, to be precise, syntax. It still can be pulled out with object destructuring. But of course now we just use it like that. We pulled it out, stored it in a brand new constant in the end, and this constant now holds a pointer at this function in the object. So now we can execute it like that. Now if we do that and we reload and we enter a new movie here, JavaScript level 5, you'll see I get an error and it's not getting added down there. Cannot read property title of undefined. Now where is this coming from? It's coming from objects.js line 58, and if we have a look, that's the line where I try to dive into info and title. Now since title can't be found on undefined, it means that info basically returned undefined. But we do have this info property which holds an object in movie, so what's wrong? Remember, this does not automatically refer to the object that kind of surrounds it. It instead refers to who or what was responsible for calling this function. And I mentioned that the best way to memorize this is to look in front of that function. Previously, we had movie dot, and therefore movie, that object, was in the end responsible for triggering this function. Now we have nothing there, and then the thing responsible for triggering the function is our global execution context. In non-strict mode, which I'm using here, this will then actually refer to the window object, which I can prove. If we console log this in here to see what it's actually referring to, and we save that and reload and we give this another try with some dummy values here, doesn't really matter. You see this here, this is what this refers to. It's my window object. And that's just a default in non-strict mode. Then this, if it refers to nothing else, refers to the global object. If we were in strict mode, which we can quickly enter, of course, by just adding use strict at the top. So if we were in strict mode, if we tried it again, you will see that this will actually be undefined. Either way, it will never refer to my movie. So how can we work around that then? How can we make sure that this refers to the right thing? We can do that with something we already learned about earlier in this course, the good old bind method. In the past, we used bind to pre-configure which arguments a function takes, which we don't execute on our own, but which, for example, is added to an event listener. So for example, we would have used bind in situations like this if add movie handler would require certain arguments, which it doesn't, but if it would need that. Now we can also use bind to not only pre-configure arguments a function will get, but also to pre-configure what this will refer to. So in this case here, of course, one fix would be to simply go back to movie dot, right? This worked and there's nothing wrong with it. But if that isn't an option, or for whatever reason we don't want to do it, we can use bind here as well. Not here. You can't add bind here like this. But you can actually do it before you call that function here. So we could actually use let here instead of const, so that I can assign a new value to get formatted title. And then we could set get formatted title, which is a variable that holds a pointer at a function, equal to get formatted title, but now also add bind here. And now it's this first argument which you pass to bind, which matters. Previously, I said this doesn't matter because we hadn't learned about this yet. So we set it to null in the past, and then we added our arguments, which was the thing we were interested in back then. Now we might still be interested in passing in certain arguments, and we can still add them just as before if that's the case. Here, however, that's not what I'm interested in, but instead now the first argument is the important thing. You can see it's the this arg. It's in the end what you want this to refer to inside of that function. Now we can set this to this to make sure that this inside of the function refers to the same thing this refers to here. But that's not what we would want, because this here would not refer to movie. You can always console log this to see what it refers to. So we don't want to pass in this here, but we don't have to. We can pass in movie, for example. And now we're saying when this function executes, which it does here, then this inside of the function, so here, this keyword, should not refer to what it normally would refer to, which is the thing that is responsible for executing the function, but instead, in this example here, it should refer to this movie object. And therefore we now fix this. If we now save that, and we reload here, and again I enter JavaScript level 5 and I click add movie, it works as before. And this is our console log where we log this inside of the get formatted title function. And you see here indeed that is our movie. So this refers to the right thing, as we can also tell by the fact that we're not getting an error and that we do have the right output down there. So bind is really useful for also managing this. Now you might argue though that this syntax is a bit redundant, or this code here is a bit redundant. We pull out get formatted title just to then reassign it to itself with the right this configuration. And you'd be right, bind is useful whenever you want to pre-configure a function for the future execution. But here we actually plan on executing the function right away. So instead of doing that, we can also use a different method which we can call on a function. I already mentioned it briefly earlier in the course, but there I said that we would dive into it later. Well, now is later. Besides bind, you also have call. Call also takes multiple arguments. The first argument, just as for bind, is what the this keyword should refer to inside of the function that is about to be executed. Second, and more arguments, you can add as many as you want, are then the arguments that are passed into the function if it needs any. Now here we don't need to pass in any arguments, so I'm only interested in the first parameter which we pass to call, and that again would be movie here. So how is call different from bind then? Well, bind prepares a function for future execution. Bind returns a new function object in the end, which we then store here in get formatted title. Call does not do that. Call instead goes ahead and executes the function right away. So it's like if you added parentheses here, but with that extra twist of allowing you to override what this inside of the function refers to. So it executes a function for you when you want to change what this refers to. That's where call is important. And therefore now if I reload, we'll also see that this works again. If I output JavaScript level 10 to mix things up really hard here, and we see that works. So that's call. And we also got apply. Apply is pretty similar to call. It also will execute the function right away. The difference is that their first argument still is what this should refer to, but then you don't have an infinite amount of additional arguments, but instead it only takes one additional argument, and that, however, has to be an array. And that can now be your values for the different arguments this function might be taking. So in the end, the difference is call allows you to pass additional arguments as a comma-separated list. Apply allows you to pass additional arguments as an array. Up to you which one you use. Here we don't pass in any arguments, so it makes absolutely no difference, and I'll therefore go with call, but apply would work just as well, as I can actually prove by using that instead. If we now use JavaScript level 11, it works. So that's call and apply and bind, which help us manage this, which can be hard to wrap your head around, but always keep in mind, this inside of a function always refers to what called that function, or to be precise, always refers to the thing in front of your function execution here, you could say. So here we have nothing in front of it, hence it's the global context. Now, one use case where this thing in front of your function execution will not really work is, for example, when you bind or set your function on an event listener. So the key thing really is that this refers to what called a function. The thing with what's in front of the function only works if you're executing the function on your own in your code. If you're setting it to an event listener, like we're doing here with add movie handler, then we'll see something interesting. If I console log this in, let's say, the search movie handler, which is also bound to an event, then what would you expect that this refers to here? Well, since there's nothing in front of it, it would be the global context, right? But that's wrong. Again, this what's in front of it thing only makes sense if you're executing the function on your own. So if you add a parentheses or if you're using apply or call. Here we're not doing that. We're indirectly executing this, if you will, by binding it to an event listener. So therefore we have to focus on the first definition I named, which is that this refers to who's responsible for calling this. And here, that will actually be the event, if you will. So the browser will trigger that event, or we click on a button, the browser then triggers the function. So the browser is kind of responsible for executing this, but in the end, it's this event which is responsible, right? It's this click event, which in the end is responsible for triggering this function. And if we break that down even more, it's the button that is responsible for executing this, right? And that's actually how the browser configures this. When a function executes based on an event, then this inside of the function will actually refer to the object, to the element that triggered that event, which in the end triggered that function. However, that's now also important only if you're not using an arrow function, because there is something special about arrow functions, to which I'll come back in a second. For now, let's switch this to a normal anonymous function with the function keyword, and then save this, and let's have a look at this. If I reload and click on search, we indeed see the button is output there. So this inside of a function that's triggered based on an event listener refers to the element or to the thing that is responsible for triggering this event. Now, I said for arrow functions that would be different though, so let's have a look at that now. Now, I said for arrow functions that would be different, so let's have a look at this now. If I switch this back to be an arrow function and we log this, let's save that, nothing else changed, and click on search, and now we see it's the window again. Arrow functions have a lot of advantages, for example, shorter syntax and so on. And one other advantage which they have, which really only makes sense now that we know about this, is that they don't know this. Every function has its own this. Every function created with the function keyword or with this method shortcut here has its own this binding. So in the end, it ensures that this inside of the function is bound to something. It's bound to whatever is responsible for executing the function. Now, arrow functions don't bind this to anything. Therefore, if we use the this keyword in there, we're not getting an error, but this simply is not overwritten by the function. This instead refers to the exact same thing it would refer to outside of the function. So here, for example, and this, just in our script like this, will refer to the global window. That's what this would refer to. Now, if you paid close attention, this might be strange. Shouldn't use strict lead to undefined being logged here? Why do we log the window? Use strict indeed leads to undefined being logged instead of the global window object if you're using this in a normal function with the function keyword and this is not bound to anything else. That's the use case we had earlier, a few lectures ago. Now, arrow functions don't know this. They don't know the this keyword. Therefore, they don't trigger this strict mode fix or however you want to call it, where this inside of functions doesn't lead to the global object being referenced, because this inside of an arrow function behaves exactly like this outside of that arrow function. Because, again, arrow functions simply don't know this. They don't assign any special meaning to it. This instead just behaves as outside of the arrow function, and there, strict mode does not lead to this not referring to the global object. That's just a fix that is applied to this inside of normal functions that's not bound to anything else. So that's one special behavior about arrow functions. And here it might look like an undesired behavior. It certainly is if you're interested in getting that event triggering thing. Though, as you will learn in the events module, there are other ways of getting access to that. But then this might be undesired, but actually in a lot of use cases, arrow functions can fix strange this behavior. Now let's see if they help us here with getFormatted_title. If we switch away from that shorthand to an arrow function notation, let's see how that now behaves. If we save that and we reload here, and I enter JavaScript level 5 and click add movie, I get an error. And we see here, this is what's getting logged from line 60, which is exactly that log inside of this function. And we see that this again refers to the window function, not to the surrounding object, because this refers to the same thing it would refer to outside of the function. Now you might say, that's the object, but that's not the case. You can't write this here. This would be invalid. Outside of the function, this object isn't a thing where you could write any code. You can't just have key value pairs in there. So the next place where you can write code is here. And that's again in your main script. And therefore this refers to the global object, and that is our window here. So here an arrow function of course doesn't help us. It just ensures that this refers to the wrong thing. And hence I will revert that here. Just keep it in mind that arrow functions don't bind this to anything. Instead, they keep the context or the binding this has to the binding it would have outside of the function. And it will become interesting again a little bit later once we dive deeper into objects and different ways of creating objects, as you will see then. For now, just be aware of that special behavior of arrow functions. They work differently with this than normal functions with the function keyword, and that can or cannot be desired. Right now we have no real advantage of that. Again, we'll see one later. At the moment, it's just important to be aware of these differences. Now I want to show you an example where arrow functions could be helpful though. Let's say we have a constant members, and this is an object, holds an object, where we have a team name of, let's say, Blue Rockets or whatever you want. And then we have the people key in there, which holds an array, where we maybe have Max and Manuel. Now I also want to have a method in there, get team members, where my goal is to combine the team title with the people names. Now this is not an arrow function, but a regular method using the shorthand syntax. And by hitting Shift and Enter, we can write some multi-line code here. And now here, I want to go through all people and console log the name combined with the team name. Now, one way to achieve this, where an arrow function will shine, is to use this .people, this should normally refer to this object, depending on how we call get team members. So this people, and then for each, execute something. So there we have a single person. I'll just use p as a parameter name here. And in this inner function here, I now want to output this name combined with the team name. So here I will say console log, and then p is that person name, plus, and then maybe a dash here, so I'm concatenating a string here in the end, and then this dot team name, right? That should work. If I hit enter, and then we call members.getTeamMembers, let's see what that yields. This should refer to our members object inside of getTeamMembers, because I'm calling getTeamMembers on members like this with a dot, so this should refer to members. And if I hit enter, I get max blue rockets, manual blue rockets, and so on. Now I do get this because I created this with an arrow function here inside of for each. Now let me show you how this would work without an arrow function there. Copy that and reload the page to recreate this members object. And now let's instead use a function with the function keyword here, which gets that person. And the rest is the same, so the logic doesn't change. Just the way I define this function inside of for each changed. If I now hit enter to create that members object, and I now call get team members, we get max undefined, manual undefined. Previously it worked, now it doesn't anymore. Why is that? The reason is the way we create this function, which we pass to for each. Now when I create this function like this with the function keyword, this is bound. I mentioned that functions created with the function keyword bind this inside of them. Now to what is this bound here? Well, let's have a look. Let's copy that again and reload, and then also add another console log statement here where we console log this inside of this inner function. If I now call members get team members, we see this is what this refers to inside of that function. It's our good old window again. Now, why is it the window? Because here we define this function. This function gets executed on our behalf by for each. And that in the end happens when we call get team members here. So we don't know how exactly the browser executes function here for us. For event listeners, we saw that there it would actually bind this to the object that triggered the event. That was something the browser did. Now for each, it doesn't seem to do any binding, and therefore it just lets this, well, be bound to the global object. It certainly does not bind it to the surrounding object, because this function gets executed because of for each, which is inside of that object, but that's the only connection. It's not our object itself that would trigger this function somehow. Instead, it's for each, and therefore the browser, which triggers this function. So this has the wrong value when we use it like that, and the correct value if we use an arrow function instead here inside of for each, because the arrow function doesn't change the binding of this, and therefore this has the binding it would have if we write it outside of this function. And what is outside of this function? Right, it's the get team members function. And what is the binding of this in get team members? It's our object. That's why it works if we have an arrow function here, and why it doesn't work when we have this function. This function tries to bind this, and it binds it to what this refers to when the function executes, which is the global object. With an arrow function, this is bound to nothing, hence it keeps its reference it would have outside of this function, which is inside of the get team members function, which is this members object. Now, if that is a lot of new information to digest, don't worry, we'll work a lot with this and with objects throughout the next modules and throughout the entire course. So there will be plenty of places to practice this, but the general idea of this should be clear right now. And definitely re-watch these last lectures to get a good understanding of what this refers to and how it behaves in JavaScript, because it can be difficult to grasp. And therefore, it's super important to have a solid understanding of that and to really go through these explanations where I do explain what this refers to. Enough about this for now. There's one last nice feature which I want to introduce here, and that are getters and setters. Now what's that? Now we have normal properties here, info for example, and sometimes we want to control how a property can be set, so how a value can be assigned, or how you can get it, so how you can retrieve it. Let's say here on our title. Here I'm checking the validity of the inputs, and then I'm assigning these properties all in one go when I create the new movie object. Well, let's say for the title, so for properties where we know in advance that they will be part, I want to do that differently. I'll remove the title check up there and remove it from down there from info. Instead, what I'll do here in info is I will add a special keyword, get, then the property name of my choice, in this case still title, then parentheses as if this were a method, and then curly braces for the method body. Now what this will do is it will create a so-called getter. So JavaScript detects this special get keyword, and in combination with a method thereafter, this can actually be accessed like a property, so without adding parentheses to call it, in quotes, but still execute some logic to retrieve the value. And the same can be done for setting. We can add the set keyword, then the property name, and then again, parentheses and curly braces. Now here for setting, we also have to accept the parameter, and that's the value parameter. Of course, you can give it any name you want, which holds the value you're trying to set. Now inside of the setter, you can now target a property with this, which refers to new movie, if you call new movie dot title later. And for example, set another property here, not the same, so not title, but often you use something like underscore title to make it clear that this is like the internal value, and for the outside world, you have title with your getter and setter, and set this equal to val, for example. But here you can now also perform an extra check and see if val trim is equal to an empty string, and if that is the case, maybe set this to another default value, default like this, and then return to not continue with this line here. Now, of course, the result will not be the same as before. Before, we stopped the entire function execution for an invalid input. Now I continue and I just set a default value, but that's exactly what I want to show. If you have such a scenario, you can use a setter to do some validation when a value is assigned to the title property and either accept it or set any other value. Well, and for a getter, you now have to define what you want to do if people try to access title. You can also omit it, then you have a non-readable property. By the way, if you omit a setter, you have a read-only property. But here I added both, and here I will just return this underscore title, so referring to this internal property which I create here on the fly. So how do we now use that? Well, you can simply go to the line after this new movie creation here, and then call new movie.info, and then in there, title. You use it like a property, so you don't add parentheses here. Instead, you can assign a value like you assign it to a property, because setters and getters are a special kind of property, a special syntax understood by JavaScript. And you can, for example, assign this title here, which we got there. So now if that title is empty, we'll not stop here because I'm not checking for an empty title anymore. Instead, this setter, which will be triggered whenever we assign a value to this title property, because the setter is on title here, will then check the value we try to assign. This value here, which we assign, is automatically passed in as this single parameter here. And then we either accept it, or if this happens to be empty, we set a default. And the getter is triggered whenever we access the property, for example, like this. When I access it and want to read from it, then the getter runs. So then JavaScript looks for this title property, and again, even though this looks like a method, we don't execute it as one, because combined with the get keyword, JavaScript allows us to access it like a normal property, and it will execute this function for us. And here we could also do additional transformations, additional checks. For example, here we could add our to uppercase transformation, and we wouldn't need this method anymore. I'll keep that method for reference though, but this would be an elegant way of always converting this title to uppercase when we retrieve it, even if we saved it in different casing. But again, I'll not do it here to keep that code. And hence here, I'll just return the unchanged code. Now let's have a look at this and reload here. And if I now enter JavaScript here and enter the other fields here as well and click Add Movie, JavaScript is getting logged here. That's from line 74, which is where I access my getter, so that works. And setting also seemed to work, otherwise we wouldn't be able to get it, and otherwise we wouldn't get the output down there. Now, side note, you also see that internal variable now being reflected here as well, the underscore title thing. You would have to exclude this now here in your if check by also checking if key is, and if key is unequal to underscore title, so that this is not output. So this should be added if you plan on using this pattern here, so that we don't output the underscore title when we go through all properties. So getters and setters can be nice if you want to add some extra validation, maybe a fallback, or add some extra transformation when getting a value. And as I mentioned, what also is nice is, of course, that it allows you to also work with kind of read-only values. If we wouldn't have a setter here, if we try to assign it like this, we'll actually get an error. If I reload here and we try to enter JavaScript here and then any values here, you see I get an error because I can't set a property which only has a getter. So this allows us to add read-only properties and make sure you can only assign it here initially maybe, but never thereafter, by adding a getter but no setter. You can also add both or none of that. You'll not need getters and setters for every single property you use in your projects. Actually, you will only use them sometimes, but it's nice to know about them and to be able to create read-only properties, to add extra validation with fallback values, and to also set up some default transformations for when you're reaching out to some data, for example. And with that, we're done with this objects module. Now, the next modules will actually also talk about objects and about different ways of creating objects, for example, and dive into the more advanced topics that are related to objects. Because it turns out you can use them for so much more than for the already a bit advanced data storage we're doing here. But again, we're just scratching the surface here. Nonetheless, these are super important concepts because you will also work with objects in exactly that way a lot. What you're going to learn in the next modules will not render this knowledge here obsolete. Instead, it will add on to this knowledge and give you different tools for different jobs. And knowing this syntax, how objects behave, knowing about this and how this behaves, knowing about arrow functions and this, about bind, call, apply, and knowing all these things about object destructuring, the spread operator, and how properties and methods are related, what they do in objects, is super important. That's the bread and butter of JavaScript, I would say. The next modules will add on to that. They will add very important additional pieces of information which allow you to write even more powerful applications with more reusable code and really awesome features related to objects. But you need to understand these basics here in order to understand the next modules. So really make sure that these concepts here and these ideas about objects are set.